Now, Watson isn't a technology. We always get asked, so what's the breakthrough technology? And I have to share, there isn't one. And in fact, arguably the technologies that represent Watson have been around for years, in fact, for decades. What's unique is Watson's a system of systems. There's 41 subsystems that have been pulled together. But rather than talk about 41, because I think it would take a while, let's really focus on the three that truly define and differentiate this particular technology stack. One we've mentioned is natural language. And again, this isn't just speech recognition, right? This is absolutely understanding the context of what and how it's being asked. And think about this. If you got 10 people in a room, you gave them all a piece of paper and asked them to read the same question, right? We would express it differently. You know, left to our own devices, we would embellish it, we would add modifiers, or we would recharacterize the question, or we would start the question with an example. And so Watson really had to be able to adapt to that environment. Two, Watson's capable of taking a question or an input and breaking it down semantically and synaptically to its subcomponents. Again, it needs to truly appreciate what question's being asked, and the only way it can do that is by the generation of hypotheses, right, and the evaluation of those hypotheses against a possible set of responses, which are then weighted, right, using analytics, using algorithms, to determine which of those possible responses. Now, to understand the magnitude here, if I asked Watson a question, Watson typically would break that down into 1 to 300 variations of that question, and from that would generate 1 to 300 iterations of responses. So you start to get a sense for magnitude of the thousands of possibilities that it's processing in the case of Jeopardy, in these 3 seconds. And then it gets to a response that has a degree of confidence, and independent of whether that response is the right response or the wrong response, Watson's going to learn. It's going to get smarter with each iteration. Now, think about the implications for just a second, right? We all talk about, good data and bad data. Well, Watson doesn't think about good data and bad data. It thinks about data in the context of how to get to the right response. And if it gets to the wrong response, it will learn and get smarter on the next iteration, right? So it can determine really good data from bad data by virtue of the actions or outcomes that occur as part of the process. So Watson is built on I'd say a relatively traditional architecture. It's got a data platform, an analytics platform. There's a Watson engine, right? That Watson engine has things like the natural language processing capabilities, the annotators, the algorithms, the ability to store and manage the data. And then everything is delivered through essentially a user application or interface. It may be embedded into another application. It may be a standalone. It is specific to the industry. And the reason it's specific to the industry is that the data that drives the insight is unique to the industry. The data for lung cancer is very different than the data for making a financial decision. And again, we got to train Watson. Today, that's a challenge. Every time we ingest big data, we take it offline and we iterate and train. In the future, we fully anticipate that will be done real time through an automated iteration where it doesn't have to be taken down.